The light changes all the time. Betelgeuse's pulsations are caused by a process called convection, in which hot gas rises and cooler gas sinks. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. With the Hubble Space Telescope, we've got detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models of the star's behavior to figure out how it might behave in the future. Betelgeuse's surface is also covered in dark spots, also known as star spots or magnetic spots, which are areas on the surface of the star where the magnetic field is particularly strong. These regions are cooler than the surrounding gas because the magnetic field inhibits the flow of hot gas from the star's interior to its surface. This creates a sort of cooling effect that makes the spots appear darker than the surrounding gas. The magnetic field on Betelgeuse is believed to be several thousand times stronger than the magnetic field on the Sun. This strong magnetic field causes gas on the surface of the star to become trapped in loops or arcs, creating regions of intense magnetic activity that are visible as dark spots. The presence of star spots is not unique to Betelgeuse. Many stars, including our own Sun, have them. However, the star spots on Betelgeuse are particularly interesting because they are much larger and more numerous than those on the Sun. The spots on Betelgeuse can be several times the size of Earth and cover up to 20% of the star's surface. The presence of star spots can also affect a star's brightness and cause it to vary over time. This is because the spots are cooler and therefore emit less light than the surrounding gas. As the star rotates, the spots move in and out of view, causing the overall brightness of the star to fluctuate. In the case of Betelgeuse, the star's pulsations also play a role in its brightness variations. As the star expands and contracts, the spots can move in and out of view, further contributing to the star's variability. One of the craziest things is that Betelgeuse isn't as one of a kind as you might think. There may not be many stars exactly like it, but there are some that share some similarities and are just as fascinating. One of Betelgeuse's cosmic cousins is Antares, a red supergiant located in the Scorpius constellation. Antares is also a variable star, meaning it changes its brightness over time. Like Betelgeuse, Antares is massive, about 12 times more massive than the Sun, and has a radius that's about 700 times larger than the Sun. So it's pretty safe to say that Antares is no shrinking violet. Another star that's often compared to Betelgeuse is Mu Cephei, also known as the Garnet star. Located in the Cepheus constellation, Mu Cephei is one of the largest known stars in the universe, with a radius that's about 1,650 times larger than the Sun. Like Betelgeuse and Antares, Mu Cephei is a variable star and is one of the brightest stars in the Milky Way galaxy. Although Betelgeuse is unique in its own way, these stars are equally intriguing in their own right. Each star has its own set of properties and characteristics that make it distinct, and it's fascinating to study them all and compare their differences. To explain the difference, we're going to be using our Sun as the point of comparison, because that's something we all know plenty about. While Betelgeuse, Antares, and Mu Cephei are all red supergiant stars, they each have their own unique properties and characteristics that set them apart from one another. One of the main differences between the three stars is their size. Betelgeuse, for example, has a radius of about 1,000 times that of the Sun, while Antares has a radius of about 700 times that of the Sun. Mu Cephei, on the other hand, is even larger, with a radius of about 1,650 times that of the Sun. Another difference between the three stars is their brightness. Betelgeuse is one of the brightest stars in the night sky, with an apparent magnitude that varies between 0.0 and 1.3. Antares fluctuates in the same general range too, but can get slightly brighter at times. Mu Cephei is much brighter though, with an apparent magnitude that varies between 3.4 and 5.1. The stars also differ in their mass. Betelgeuse is estimated to have a mass of about 11 times that of the Sun, while Antares is thought to have a mass of about 12 times that of the Sun, making them around the same size and brightness. Mu Cephei, however, is much more massive, with a mass estimated to be around 20 times that of the Sun. Finally, each star has its own unique set of properties and behavior. Betelgeuse, as we've discussed earlier on in the video too, is known for its pulsations, which causes its brightness to vary over time. Antares, on the other hand, is surrounded by a massive cloud of gas and dust, which may help explain its unusual behavior. Even though it's technically brighter than Betelgeuse, the dust and clouds around it keep it from appearing as bright. Mukafei, meanwhile, is known for its extreme luminosity, which makes it one of the brightest stars in the galaxy. But it's not as volatile as Betelgeuse. You see, while we've mentioned the pulsations, the color, and the overall behavior of the star already, there's one thing that all of that ends up meaning. It's that a supernova is imminent, and it might be coming up fast. Now, when you first hear of it, a supernova sounds glorious, and in a way it is. But when you really begin to understand it, it's terrifying. Supernovas are incredibly powerful explosions that occur when certain types of stars reach the end of their lives. These explosions release huge amounts of energy, creating some of the brightest and most energetic events in the universe. There are two main types of supernovas, Type 1 and Type 2. While the Earth is at a comfortable distance away from the star, with events like this, you never really know how crazy things might get. Could the Betelgeuse supernova take the Earth along with it? We'll pass the question on to you. Let us know what you think in the comments below. If you like this video, please give it a thumbs up and we'll see you in the next one.